All right, guys. We're gonna be talking about weather right now, and you can see on the computer screen right here. This can appear on your on the benchmark, on the second benchmark. So we're gonna go over some of the topics really quick in this video. And again, we're trying to keep it between 5 to 10 minutes. But of course, I can't go over 10 minutes. If I can finish it earlier, I will. You can see the SOLs right here that observation and collection of weather data, prediction of weather patterns, severe weather occurrences such as tornadoes, hurricanes, and major storms. And this is the essential understanding underneath here. And weather and climate are different. Weather basically happens on a day-to-day basis, where climate happens over thousands, maybe even millions of years. Um, so that's what that's saying right there. That's the main difference between them. The conditions necessary for cloud formation are air below the dew point. So basically, what's going on is when a cloud is being formed, maybe I can pull up an image right here. So cloud formation. When clouds are being formed, you have warm, moist air going up, and as it goes up in the atmosphere, you have it getting colder as it goes up, and the water, the warm, moist water vapor starts to condense. And what it does is it condenses on something called condensation nuclei. And condensation nuclei can be anything like small sand granules, dust, bacteria, even down that is floating in the air. So here, like I was talking about, warm, moist air is going up, and then it gets colder. And once it gets colder, remember, cold air can't hold moisture. Warm air can hold a lot more moisture than cold air. So as the water is going up, the warm, moist air, it's got to condense because the cold air can't hold the moisture, and it condenses onto something called condensation nuclei, and the clouds form. As it gets bigger and bigger, as those little droplets get bigger and bigger because more is attaching to it, it begins to get too heavy to hold up in the upper atmosphere, and it falls down as rain. So that is basically how the clouds form. All right. A tornado is a violent funnel shaped column of spiral winds. And the strongest right here about a hurricane compared to a tornado. All right. Well, a tornado is a violent cyclone, and it spins in an a counterclockwise movement. Actually, both of them do. Hurricanes and tornadoes both do. The most powerful storm on the planet is a hurricane, though. Hurricanes for the East Coast, or that affect America, primarily originate on the west coast of Africa. Maybe I can get an image of that right here. I'll go ahead and close this, and I'll type in hurricane formation. Misspelled that. And I'll say Africa. Let's see what's going on here. All right. Well, you see some images right here that are showing that. Okay, you have these hurricanes that form right here off the west coast of Africa, and these air masses. This air mass right here would definitely be a maritime tropical, and it's pushing that these tornadoes in that direction right there. So they originate as a tropical storm off the west coast of Africa, and they make their way towards the east coast of America. And go back to your pacing guide. Let me see. These are how they break them down. I don't think they're going to ask you like that. Identify and describe the direction of local winds like land breezes and sea breezes. I'll go ahead and pull an image of that up. Land breeze versus sea breeze. Land breeze and sea breeze. This is what I was talking about in one of the previous videos that you guys watched on Friday. Talking about land breezes and sea breezes being basically thermals or unequal heating in a specific little area. And I'll go ahead and pull this image up. It looks pretty good. During the day, you have basically the land heating up a lot quicker than the cool water. And so you'll have a high pressure here and a low pressure here. You'll have this warm air going up and the cold just the cold, dense air filling that vacuum, and it heats up here and then goes back up. And at nighttime, so during the day, it's coming from the sea. That's why it's called a sea breeze. And at nighttime, is a land breeze is coming from the land, and basically it flip flops. The ground cools a lot quicker, and the water still hold onto that heat, because remember I told you that water can hold on to heat very well. And so here you have a low pressure, and here you have high pressure. Okay, I'm gonna end this video right now, and another one will be coming here very soon. Thank you for watching.